Now we will learn how to draw the graphs of the 6 trigonometric ratios or functions. For that I will refer the NCERT textbook page number 59. Here we are given a table where we are told in the 4 quadrants how the various trigonometric ratio values are either increasing or decreasing. Just I'll show a glimpse of it, like sine. In the first quadrant means what? 0 to 90. You remember sine 0 was 0, sine 90 was 1. That means 0 to 90. In the first quadrant, sine value increases from 0 to 1. Then in the second quadrant means 90 to 180. Sine value decreases from 1 to 0. That means sine 180 is 0. Sine 0 is 0, sine 180 is 0. So by the end of second quadrant, sine once again becomes 0. Means sine is maximum at 90 degrees and maximum value of sine is 1. Minimum value of sine in first quadrant and second quadrant is going to be 0. In third quadrant, sine value decreases further from 0 to negative 1, and in fourth quadrant sine value increases from negative 1 to 0. That means this is a one cycle, means 2 pi. And why this information is given up to 2 pi? It is because the trigonometric ratios sine, cos, sec, cosec, these 4 trigonometric ratios are periodic and their period is a 2 pi. That means after every 2 pi round, means after every 360 degree completion, they repeat the same behavior. That means from 0 to 90, sine value increases from 0 to maximum 1. Then in the second quadrant, from 1 it decreases to 0. And then in the third quadrant, means 180 to 270, its value further decreases to minus 1. And then in fourth quadrant, that is 270 to 360, means a 2 pi. 3 pi by 2 to 2 pi, means 270 to 360. Its value increases from minus 1 up to 0. So sine of any angle, its minimum value is minus 1, maximum value is 1. So sine of a value lies between minus 1 and 1. So this information from the textbook I will use while drawing the graphs. And while drawing the graphs, I may need the domain and range of the trigonometric functions. For that I will use the Arihan publication on the book Trigonometry. Now let us begin how to draw graph of trigonometric function. So I kept some x-axis, y-axis ready for, here I am going to show sine graph, and here I am going to show cos graph, here tan, and the next page I will go for sec and cosec and cot. So on the x-axis, positive x-axis, I have shown pi by 2, 0, pi by 2, pi, 3 pi by 2, 2 pi. In simple terms, 0, 90, 180, 270 and 360. The same thing on the other side also, like you come to this so that you understand here, this one. So x-axis, this is 0 degree. Positive y-axis, 90 degree. Negative y-axis, 180 degree. And negative x-axis 180 degree and negative y-axis is a 270 degree. And once we cross 270, come back to positive x-axis, we are at 360. 360 is a 2 pi. So that we'll have in mind while drawing the graph. Now, because sine, all trigonometric ratios are periodic. Why we want that? Why? Because we will draw only graph for the first quadrant. See, 0 to 90. 0 to 90 we will draw the graph, and then 90 to 180 what happens, that we will guess, because by this time we have learnt in various quadrants how these values are increasing or decreasing, positive sign or negative sign. So based on the sign we can guess. I'll be telling you also how to guess. So sine, cos, their period is 2 pi. After every 2 pi, after every 360, their values keep on repeating. So graph will be like that, repeating. Tan and cot, their period is pi. That means tan and cot value repeat after every pi rotation. Fine. Now let's start drawing the graph for sine theta. how to draw graph for sine theta. Just see, for sine theta 0, 30, 45, 60, 90, and we have learned that sine 0 is 0 and sine 90 is 1. And you see, after this 0, this is 0.5, probably this is some point, some decimal, okay, 0.7, this one, 1. That means as a theta increases, sine also increases from 0 to 1. 0 to 90 is first quadrant information. So first I will draw graph in the first quadrant. Means x-axis is about theta and y-axis is about the values of sine theta. So when theta is 0, sine theta is also 0. So this is the first coordinate. Then what I do is, when theta is a 90 is a pi by 2, this one. Sine 90 is 1. That means sine of an angle is a maximum at 1, positive 1. And from 0 to 1, is it a straight line or it is some kind of curve? How to know that? For that, you see, as between 0 to 90, that means in this zone, the value increased. 0 was 0, fine. 30 means what? Pi by 6. Pi by 6 will come somewhere here, very close. Value is 1 by 2. 1 by 2 means 0.5. So if this is 0 to 1, 0.5 will come somewhere the middle. You understand? And then the value increases. Okay. So like this, for some particular value, some other particular value like this. That means a graph is like slowly ascending. It's not a straight line actually. As a theta increases, its value also slowly increases. So it's not a straight line. Just to tell you that it is kind of, I think we can close a circle. We can complete a circle with this. Radius, okay, fine. This is a curve anyway. So maximum at this. This is about first quadrant. In the second quadrant, I showed you in the textbook that sine value decreases from 1 to 0 because you see, on positive x-axis sine 0 is 0, so it increases, becomes a maximum at 90. Sine 90 is 1. Then it decreases and comes to 180. Sine 180 is again 0 because sine 0 is 0, sine 180 is 0, sine 90 is means pi by 2 is 1, sine 270 means minus at 3 pi by 2, that is minus 1, plus 1, minus 1. This keeps on repeating. 0, 0. So sine 0, 1, 0, minus 1, 0, 1, 0, minus 1, like that. The cycle continues. So I'll keep that in mind while drawing the graph. So now sine pi is 0. So between, this is first quadrant, this is second quadrant. So in the second quadrant, it slowly reduces. And then the third quadrant is 180 to 3 pi by 2, 270. In this zone, what happens? At sine 270 is minus 1. And between 180 to 270, the value, the curve is, it is a curve, not a straight line. And once again, one round over. So sine 360 is a 0. So this is the next point. So these are the end points, but we will not connect them straight because here also descending is slow descending like this. So this is in the right side. This completes a one cycle. Then I told that sine, cos, their period is 2 pi. That means after every 2 pi means 360 degrees, their behavior repeats. So this one we can just go on like this. The same thing we have to do in the left side. Left side is sine of negative values. You know, sine of minus x is minus sine x. That's the reason we will go up to negative 1 here. This will be one of the points, but it should be a curve. And this is the next point. Between them, it's a curve like this. And then at this point, it is highest. Means this is the point. So this is a curve. And here it turns 0. So it's a curve. So sine graph will look like this. Sine function graph is like this. I just hope you have understood. I just take the camera a bit closer and I will draw COS graph. Okay, so this one, COS graph. So how COS graph is drawn? Just observe here, COS of, these are the angles. Angles are in ascending order, means first quadrant, 0 to 90. But value of COS is decreasing from 1 to 0. So cos 0 is 1. So these values are x-axis information and the angles are x-axis information. The cos of those values, this is the y-axis information. So I have to search for 1, 0. No, I have to search for 0, 1. 0, 1 is this point on y-axis. Okay. Then highest value. What is the lowest value? At 90, means pi by 2, it becomes 0. So this is the connecting point. These two are connecting point. But between them, we will not draw a straight line. Why? Because from 1 to 0, it has a slow descent. Slowly it is reducing. So it is a curve like this. Then that is first quadrant. Second quadrant, what happens? Second quadrant at pi, because cos 0 is 1, cos pi is minus 1. Cos 2 pi is 1, cos 3 pi is minus 1. Means cos of even multiples of pi is 1, cos of odd multiples of pi is minus 1. Cos of odd multiples of pi by 2 is 0. So at this is odd multiple of pi, so this is 0. So I'm just collecting this one, and then here it is maximum 1, 2 pi and 1. I have to connect these dots, so that dots will be connected in form of curves because it's not straight going, because in between the values are slowly increasing. The same thing I have to repeat in the other side. At every pi, take a dip and this minus 1 line. So go up to minus 1 line for every pi, because cos of minus pi is minus 1. So from the graph, if you remember the graph, you can find cos, sine, cos, those all values of various angles, because you can see that graph went in which direction. Then this, then at minus 2 pi, it will stand maximum. So this is the graph of cos x. Now for tan, just see here, something very interesting happens for tan. Tan of an angle, tan 0 is 0, fine. As the angles increase from 0 to 90, means in the first quadrant what happens? Tan values are also increasing. 0, 1 by root 3, then 1, then 1.732 root 3 value, and then not defined. So where tan is not defined, you see, tan is not defined. Tan of an angle is not defined at 90. 90 means a pi by 2. So you remember that tan of an angle is not defined at odd multiples of a pi by 2. Means it's not defined at 90, not defined at 3 pi by 2, not defined at 5 pi by 2, 7 pi by 2, 9, 11, 13, like that. So where tan is not defined, that these angles, no, there we will draw demarcations, like tan of 90 is not defined. Not defined means infinite. So at pi by 2, I am drawing a demarcation because tan doesn't exist there. Tan doesn't exist here, tan doesn't exist here, tan doesn't exist here, like that. So where tan of an angle is not defined, I have drawn. Then what happened, you see, tan 0 is 0. So definitely this is a point. And from this is 1 point. At 90 it is not defined, means the graph will never touch the pi by 2 line, but it is increasing, that is slowly increasing. So here we can take the graph like this, and its image will come in the bottom one, negative angle, like this. So actually this is a slow, like this you can take. Okay. Then the same graph we have to repeat. That is, a tan of the function definitely crosses x-axis at 1 point. Why I am saying this? You will know when I, tan of an angle definitely crosses origin. Why I am saying this? Because cot of the angle, cot theta graph, when we draw, we will realize that cot doesn't pass through 0. Why? Because tan 0 is 0, but cot 0 is not defined. Okay, so tan graph will look like this. It will cross the even multiples of pi, means tan is defined for even multiples of pi. N is even, so 0 considered as even number. 0 into pi 0, 1 into pi, yes, it has become yeah, tan of 0 is 0. All right, so correct, this is theta. So when n is 0, tan of n pi is also 0. That is why wherever we see pi or even multiples of pi, odd multiples of pi, the tan graph will cross that like this. So here there is 5 pi by 2, the line, and here also the graph similar. Like there's a lot of symmetry. These graphs are nice symmetrical graphs. This is how the tan graph looks like. It is a bit like illusion kind, but you remember only one point. The graph will be between minus pi by 2 plus pi by 2, and it is kind of a rising graph, or you can say it is a falling graph, but it will cross origin. Okay, so between every odd multiples of pi by 2, you have to draw lines, and the graph will cross at even multiples of pi. Now to draw the graph of sec theta and cosec theta, observe this. Sec is a reciprocal of cos. Cosec is reciprocal of sine. So sec 0 is 1, and you see as angle increases, means on x-axis as the angle increases from 0, 90, 180, 270, 360. Similarly, negative of the same angle. So as angle increases, what is happening with the values of sec of those angles? The value is also increasing. 1, something like, okay, you understand, 1.414, 2, and this is infinite. So not defined. So first sec, let's draw the graph for sec function. So this graph is for the sec function. First, where the graph is not defined, there we will draw parallel lines parallel to y-axis. So sec is not defined at 90. So wherever we see odd multiples of pi by 2, there we will draw lines just to tell that that particular function is not defined at odd multiples of pi by 2. Fine. So that's the first point. Similarly, I'm getting ready with cosec graph also. This zone I created for cosec. This will give us cosecant theta. Cosecant is reciprocal of sine theta. Cosecant is not defined at 0 degree. That means here the line has to be 0 degree. These angles are actually x-axis. These values are sine or cosec of those angles. So values are on y-axis. So cosec of 0 means y-axis information, that is not defined at 0. So at 0, that means point of intersection of x-axis and y-axis, I will darken it. Cosec is not defined at 0. 0 means even n pi, not defined at n pi. And sec is not defined at 2n plus 1 pi by 2. 2n plus 1 is odd multiples. Okay, so it is not defined on 0. I darkened it, and I will darken all the even multiples of pi to tell that cosec do not exist there. We can't define cosec there. The meaning is that. So here and here. So these are the demarcations drawn. Then now let's draw the graph of it. Sec, you see, sec 0 is 1. So 0 degrees of x-axis and 1. That means this is the this is the minimum value. Maximum comes at 90. So from 1 up to 90 means 0 up to 90, sec value is slowly increasing. Increasing means will not come down. We will go up. Slowly increasing. But it will not touch pi by 2. It will go beside. And after 90, the repetition occurs. Repetition means in the negative zone, it will be like this. All the trigonometric graphs will be symmetric about a particular axis. So that means once it comes to pi, this becomes minus 1. So this will be the peak of in the second quadrant. Second quadrant will take the parabola like this, and the vertex of this parabola connects to pi and -1. Its meaning is sec of a pi is -1. Similar, actually cos of pi is also -1. So sec of pi is also -1. So here the same, -1 to -pi, this is it, and the graph goes like this. Sec graphs will go like this. So some of them like this. The peak is, the peak is here and 2 pi. The graph is like this. This side also. So sec graph looks like this. At one point it will intersect y-axis, only at one point. How about cosec graphs? See, cosec 0 is not defined. Cosec 0 is not defined. That means, and where is it minimum? Minimum at pi by 2. So pi by 2 minimum point is at this. And see 90. So after 0, maximum is 90. Between them 30, 45, 60. 30, 45, 60. At this, the values are, so from infinite, lowest is at pi by 2, which is 1. So cosec graph should go something like this. It should go, this is this is that point, lowest point. Cosec graph should go like this. At pi by 2 -1, okay, this point. So cosec graph should go like this. Okay, so in this interval, this one, in the next interval, this one, in this left side interval, this one, in this side interval, it will come because after every one cycle the value changes. The graph looks like this. So cosec graph will look like this, sec graph will look like this. Just take a kind of wider picture, zoom it and see how these graphs are being drawn. Now we will find the domain and range of the 6 trigonometric functions. Domain's meaning is these trigonometric functions are defined for which values of theta. So theta is in terms of degrees or radians. When we apply like pi by 2, pi, 2 pi, those are in radians. 0, 30, 45, 60, 90, those are in degrees. So these trigonometric ratios are defined for which angles that constitute domain. And those these trigonometric ratios of those domain values is the set of range. Like sine 30. So 30 is domain. So domain is 30. Sine of 30 is what? Its range. That is 1 by 2. That is the meaning of domain and range. So sine theta is defined for all real values, R for real numbers. Whatever be the real number, sine theta has a value. But the condition is sine theta always lies between sine of an angle, that angle is a real number, always lies between -1 and 1. Minimum value of sine of an angle is -1. Maximum value of sine of an angle is +1. So range is -1 up to 1, and I will use the closed bracket. This is called closed bracket. Rectangular brackets are closed bracket, indicating that -1 and 1 are also included. Cos of an angle is defined for all real values. Same. Cos theta lies between -1 and 1. So you can guess which is minimum value and which is the maximum value. Then range of cos is also -1 to 1. Minimum value I said, no? -1, 1 included. That is why the closed bracket. Tan of an angle is not defined for odd multiples of pi by 2. So that's why all the real numbers from which we will subtract the odd multiples of pi by 2. 2n plus 1 is odd multiple of pi by 2. Here n belongs to the set of integers z. So, tan 90 is infinite, not defined. While drawing the graph, we understood. That's why. So, all the odd multiples of pi by 2, we have to remove from the set of real numbers, and for them only tan value exists. And what is the range? The range is all real values, because for these, the answer is like tan of this angle is definitely a real number. Then cosec. Cosec is like, while drawing the graph, you realized that cosec is not defined for even multiples of pi. Why? Because sine pi is 0. Sine pi is 0. Like sine 0 is 0, sine 90 is 1, sine pi is also 0. And since a cosec is a 1 by sine, so if sine becomes pi or multiple of pi, even or odd multiple of pi, this becomes 0. 1 by 0 is not defined. That's why the domain will be the set of all real numbers from which the even multiples of pi is removed. N is a integer, however. And what is the range? Range is very interesting. When we draw the graph, we realized that it is going up to -1 on negative axis. It is going up to 1. Minimum value of sine, maximum is 1, minimum is -1. So cosec lies, like cosec touches at the minimum level -1 and minimum level +1 on positive axis and negative axis. Okay, and it goes to infinite. So open bracket means infinite is generally not included, and here also it goes to plus infinite, and it is a union of this set will be the range. Sec theta, sec is actually 1 by cos theta. Cos is not defined at this which position. Cos pi, cos 0 is 1, pi is -1, but it is not defined at 90 or multiples of pi by 2. So sec is not defined at odd multiples of pi by 2. So from real number, we have to remove 2n plus 1 pi by 2. 2n plus 1 is called odd multiple of pi by 2. It is not defined. N is again integer. And what is the range? Range is once again, it will touch upon up to -1 on negative y-axis and touch upon 1 on positive y-axis and goes to infinite, and this also goes to negative infinite. This tells that this is not bounded. This tells that this is bounded, means -1 is included. Here 1 is included, a union of this. Cot is actually 1 upon tan. Cot is not defined at multiples of pi. So from the set of real number, we have to remove the multiples of pi. N is again integer. And then what is the range? Range is, if these angles are removed, then cot exists for the remaining values, all real values. So this is how we have to understand that these, which are periodic functions, for which value these trigonometric ratios can be defined, and when it is defined, what could be the answer. Based on this also, we can draw the graph of trigonometric functions.